Hello, Aggies. This is the Week 5 test, and we're going to go through each of the test questions, and I'm going to explain the answers to you, and that'll give you an opportunity to go back and look at your work and also give you an opportunity to use this to study from for the Week 6 test, because remember, on the Week 6 test, you'll see the Week 5 concept again, plus you'll see the Week 4 concept again. So let's start with question number 1. What is 30% of 40? So when we see percent of, we think of this, 30% times 40. So we've talked about this having two steps. We can see the answer. The answer is 12. Let's get the 12. So here are our two steps. Step 1, we're going to take that 30% and we're going to change it into either a decimal, 0.3, or you can call it 0.30. But remember that last zero, the one I drew in the pinkish color, doesn't have any place value, so we don't have to have it. Or you can write it as 3/10. Some students prefer to work with fractions. Some students prefer to work with decimals. So now we have step 2. And step 2, depending on how you set up your step 1, is either 0.30 times 40, that's if you did it in the decimal form, or 3/10 times 40. Now you remember from elementary school, they told you if you're multiplying with fractions and you have a fraction times a whole number, put that whole number over 1 so it's easier to follow. In this case, we can go ahead and we can do some canceling. 10 goes into 40 4 times, 10 goes into 10 one time, 3 times 4 is 12, 1 times 1 is 1. That gives us our 12. And back up on this, 0.30 times 40 gives us 12.0, which also simplifies to 12. So regardless of how you decide to do it, remember there are those two steps. In that first step, you want to change the percent into either a decimal or a fraction. And in the second step, you want to go ahead and multiply that out. You want to simplify. All right, let's look at problem number 2. Let me give myself some workspace here for problem 2. So on problem 2, Jack has 5 Snicker bars and 3 Baby Ruth bars. What is the percent? It's always important to know what question they're asking. What is the percent of Jack's candy bars that are Snickers bars? So whenever I'm doing the percent of something, I'm taking that thing, in this case Snicker bars, out of the total. So I'm looking at Snickers compared, that's a huge line, let's try that again, Snickers compared to the total. So the Snickers bars, they tell us there are 5 of them. And the total, well, we've got those 5 Snicker bars plus 3 Baby Ruth bars. That gives us 8 altogether. And so we want 5/8 as a percent. And 5/8, when you divide, let me bring down my calculator here. When you divide 5 by 8, you get 0.625. And you talked last year, and we talked this year also, about the fact that when you want to make that into a percent, you move the decimal point 2 places to the right, place in a decimal point, give it a percent sign, and that's where we get our 62.5%. Remember, as we go through this test video, anytime you want to, you can pause, rewind, take a look again at a problem. That's the advantage of having it on video. All right, let's move down to number 3. So in number 3, we are studying constant of variation. Constant of variation is change. So in this case, it tells us the number of chirps varies directly with the temperature outside. Where you see that word varies, think of the word change. So there's a consistent change. That's what varies directly means. There is a consistent change. We've talked about deciding on these problems which is the independent and which is the dependent, which one controls the other. Here they're telling us the cricket chirps are controlled by the temperature, and that makes perfect sense. Crickets can't control the temperature. It would be cool if they could. Anytime you were cold, you could just get your box of crickets out and get them chirping and everything would warm up. But that's not the way it works. As the temperature outside warms up, the crickets begin to chirp more. So we know that the cricket chirps are the Y. We've talked in the past. The Y is the dependent. It's the thing that depends on something else happening. And the X is the independent. The independent is the thing that controls the dependent. Independent. So it's important that you are able to identify the dependent and the independent. So now, constant of variation. So like a lot of things in math, constant of variation has a specific definition. Its specific definition is this. It is the change in the y value, the dependent value, divided by the change in the x value, or the independent value. Why is it that way? Because that's what mathematicians decided a long time ago. Just like this color is called blue because somebody decided a long time ago we're going to call that blue. So this is one of those things you have to remember. You have to memorize this idea that constant of variation is the change in the y value divided by the change in the x value. So let's take a look at the change in the y value. 21 to 27, that's a change of 6. 27 to 33, a change of 6. There is a consistent change by 6 in these dependent values. So we know that the change in the dependent values is 6. How about the independent values? Well, 7 to 9 is 2, 9 to 11, 2, and we can see that each of these changes by 2. So there's a change by 2 in the independent values. And constant of variation is the change in the dependent, the y's, divided by the change in the independent, the x's, and that means that for this problem, the constant of variation is 3, which they gave us right here. Now, how would you write a formula for that? Write an equation you could use to find the number of times that a cricket chirps in 25 seconds given the temperature. So we know that we're calculating the chirps based on the temperature, and our formula is right here. It is the chirps, the C value, is equal to 3 times the temperature. That's our constant of variation. This value right there will always be that constant of variation, that predictable change in the value. All right, again, rewind this if you need to. We're going to move on to the next question. All right, on to question number 4 here. So in question 4, we're talking about direct variation, and that's tied to the idea of constant of variation. Remember, constant of variation is where it varies directly, it changes directly. Direct variation means the very same thing. These types of problems, some you'll see on graphs, some you'll see set up with a story like this one. So when you see the story, you need to look for some specific information. First off, this tells you that it makes a straight line, passes through the origin. Those two things tell you that we have a proportional relationship, and I just need to spell better. So we've talked before about proportional relationships. They vary directly, so as you change one thing, there's a consistent change in the second thing. And the third piece of information here is the point 36. Remember, when you see origin, we're talking about the point 0, 0. So now we're ready to go in and start answering the questions. And what we're asked to do in this problem is decide which of these statements is true, which of these statements is false. First question talks about the slope, or the first statement says the slope of the line. So as soon as we see that, we know that we're going to need to use the slope formula that we've learned. And the slope formula is that slope equals y2 minus y1 over x2 minus x1. This is another one of those things you'll need to memorize. Remember, in math, there are certain things that you just have to memorize. They're just formulas you have to know. So let's break down the x2 and the x1 and the y2 and the y1. Let's take our 2 points. I'm going to move them right down here, the point 0, 0, the point 3, 6. And we've talked before about the fact that it doesn't matter which one you name which. One of them is going to be the 1s, and one of them is going to be the 2s. For me, I always make the bigger numbers the 2s, because I know that the next thing I'm going to do is I'm going to do some subtraction. I'm going to do y2 minus y1, x2 minus x1, and if I do large numbers minus smaller numbers, I don't have to worry about negatives. So I've got 6 minus 0 is 6, 3 minus 0 is 3, 6 over 3 simplifies to 2. That 2 is a couple of things. It's the unit rate. In this problem, since it is the unit rate, and this is talking about miles he ran in days, it turns out to be the miles per day. And of course, it is also, this is the thing we were calculating initially, it's also the slope. So since that's the slope is not a half, it's 2. All right, so A is false, not true. All right, letter B. The y-intercept of the line is 3. Anytime you have something going through the origin, you can see from that 0, 0, if it's going through the origin, the y-intercept equals 0. Technically 0, 0, but the y-intercept normally just looks at the y-coordinate. So in actuality, the y-intercept is 0. That's not true. Jason ran 2 miles per day. Well, by definition, this is the miles per day. It's the unit rate, so that one's true. And after 5 days, Jason ran 10 miles. Also true. Jason's running 5 days at 2 miles per day. That would equal 10 miles. All right, so go back and look at this if you need to. The next problem might be on a graph. They might take and actually graph things and give you a line and then ask you similar questions. On to number 5. Solve the proportion. A lot of you got this question right. So this is one we can start feeling pretty confident about. We have our proportions, which we have said in the past, we're going to solve by doing the diagonal multiplication. So we're multiplying, in this case, 5 times t, and that equals 2 times 13. We've talked about taking and using this dotted line to remind ourselves whatever we do on one side, we also do on the other. So 5 times t is 5t. 2 times 13 is 26. That's step 1. Step 2 is to divide. And we divide by this coefficient, by the 5, because that gives us a big 1. 5 divided by 5 is 1, times t is t. 26 divided by 5 is either the fraction, 5 1/5, or the decimal, 5.2. Either one of those would be a correct answer. Finally, number 6. Sophia mixes 3 ounces of blue paint with 2 ounces of yellow paint to get her favorite color. How much yellow paint, let's make sure we know the question is, how much yellow paint does Sophia need if she's going to make a total of 20? So this is a total problem. So that tells us that we're going to have the yellow compared to the total. Well, in the original, there were 2 ounces of yellow. Right here, 2 ounces of yellow compared to 5 ounces of total, the 3 blue plus the 2 yellow, giving us 5 total. Work on my 3 right there. There we go. And we know now there will be 20 ounces total, and we don't know, there's our x value, we don't know how much yellow. Now that we have that set up, we could go ahead and we could solve this problem the very same way we solved the last one. 2 times 20 equals 5 times x. And we'd go ahead and set up our line down the middle. And we'd have 2 times 20 is 40, and 5 times x is 5x. Once again, we would divide by the coefficient. We don't want to know what 5x's are. We want to know what 1x is. So now we've got 1 times x is x, and 40 divided by 5 is 8. So we have 8 ounces of yellow. I was going to write that again, but you know what? That seems silly. They've already written it for us right there. The other thing you could do, the way that I would actually solve this problem, is I would look at this relationship and say, wow, 5 times what makes 20? So let me just bring this down and show you how I would solve this. 2 over 5 equals x over 20. I would say what times 5 makes 20? That's 4. I need to multiply by 1. As long as I multiply by 1, things don't change. 4 times 5 is 20. 4 times 2 would give me my 8. So there you go. You've got some work that you can review now. You can look back over those problems, so please do that. Be checking those out, and then use that as one of your things to study for the next test. All right, if you have questions, bring them to class.